Hello. Hi. Okay. I'm going to send you check email. Looks like this. You got it? Again, I emailed you previous quiz number 3. Check your email. Next Monday, you will take a quiz number 3. Similar to this problem. Okay, are you ready? And also, if you can, turn on your camera. Thank you. Okay. Following table shows cost to produce each unit of a product. This problem doesn't give the initial cost, K, and also it doesn't give us learning percentage. So first step, figure out learning percentage and K. When we did the example and practice problem, the same. When it's doubled from 1 to 2, 2 to 4, times B. So first, figure out what is B. The relationship y fourth equals y second times 2, then times B, right? So we need B equals Y first divided by Y second. So B equals Y fourth divided by Y second 4, 6, 7, 5 equals 0.85, 85%. And then again, Y second, this one, equals K times B. So when we know don't know K, to get K equals Y2 divided by B. So K equals Y second 4, 6, 7, 5 divided by 0.85 equals 5,500. So far, question? Can you do it? Okay. Question A, how much is total cost to produce 50 units, 11 to 60? So this one is cumulative. $11 to $60. So that will be $60 minus $10. So Y11 to 60 at 85%. K times cumulative factor.
I just have a quick question.
Yes.
Where do you get the 10 from?
From 11, right? From 11, 11, 12, 13, 14, up to 60, right?
Okay.
1, 2, 3, 4, 10, right?
Okay, thank you.
Got it?
Yep, thanks.
Yeah, why it is not 10? Okay. So from 11, you subtract up to 10, right? Okay, good. So 11 to 60 equals K times cumulative factor 60 minus cumulative factor 10. Okay, then I will bring up the Just a moment. Chart. From this chart, this one is on Moodle. Cumulative factor 60, 85, 29, 41. Cumulative factor 85, 10 is 7.116. So K equals 5,500 and cumulative factor 60 is 29.41 minus cumulative factor 10 is 7.116 equals 5,500 times 22.2954544 equals 122,617. This is answer. Question? Okay. Can I erase? You need more time to write down? Okay, I will erase for next question. How much is cost to produce the 88th unit? Single unit. So Y 88 at 85% equals K times unit factor $88, 85%. So try to find $88, but there is no 88. So this case, I said, try to half of that one divided by 2. 88 divided by 2 is 44, but still cannot find. Again, 44 divided by 2, 22. Yes, we can find. So 88 cannot find, divided by 2, 44, cannot find, divided by 2, again 22. So if we can find 22 to get 88, we need times B and B again. So unifactor 88 equals unifactor 22 times B times B, so square. This is 85%, so 22 this one. So 0.4844 times 0.85 square. That will be 0.349979. So equals K is 5,500. Unifactor 88 is this one. Equals 19, 24, 88. So if we use the charts, find half of that one, 22, and then times B, using arithmetic learning curve concept, or you can use logarithmic learning curve formula K times X log B divided by log 2 equals K is 1,500, X is 88, the unit number, log 0.85 divided by log 2. This part is this one. then it's approximately 1925. So either way, using arithmetic learning curve concept and then table, the charts, or using formula. Either way is okay. Okay, question? Good. So next week, next Monday, you will take quiz number 3. Almost the same, change numbers, but basically the same, okay? Okay, chapter 5. Project management. Always, when start a new chapter, I uploaded lecture note. And if you need a practice problem, also on Moodle. Okay, project management. First, define what is project. When we say project, usually it is a large one to something a large one. For example, if my next year project is build a house, to do that, what I need, maybe search area where I want to build. If we decide on a location, then I may need a contractor. With a contractor, decide what type of house, like 1 story, 2 stories, how big, and so on like that. Blueprint. After that, before that, now we need to buy that land, and then permission, and so on. Then contractor dig, and then foundation, and so on like that. So project, big one, and then consists of many works or jobs, interrelated tasks, and then a series of related jobs. Series of related jobs. Before I buy a land, or before I have the permission, we cannot dig, right? So something first and then something follow. So related each jobs, and then maybe there is like a sequence. So many works consist of many works, and then they works jobs related. That is project. Project management. The management activities to achieve objective. What kind of objective? Complete the project in time or maybe a shorter time, like a faster, and then build a house, high quality house, and then in budget, or make it cheaper. So to achieve objective or objectives, manage activities. What kind of activities? Planning, directing, and controlling resources, such as people, workers, equipment, and materials. So manage those activities to that is that management. In project management, time is very important. Complete the project in time. Make it faster or in time and in budget. Time management is very important. So you network planning methods manage projects, because project is made of a sequence of something first and then next on. Maybe there is sequence or order. And then usually in projects, activities are related. And then later with an example I will show you, but I'm out again, but I'm back. Are you there?
Yeah, but it's cutting in.
Okay, again. Cut again. Now is okay. Okay, good. Thank you. Again, in project, many passes related works, jobs.
If you're
Among
sharing your
them-
screen, we can't see it.
Okay.
Thank you.
Okay, sorry. I don't know why. Since last week, network unstable. But anyway, please understand this time. Okay, pass among possible passes, longest pass take time is critical path. So especially manage this critical path. If critical path delay, then entire project delay. So we call critical path method. Using critical path method, CPM, manage project. I think you heard PERT and CPM, project tool method. PERT, CPM. CPM is critical path method. PERT is program evaluation, and review technique. When we say PERT and CPM, those are network planning models for project management. Usually, CPM, critical path method, without cost information, just time manage, using only time information. PERT, using time and cost information, time and cost information, manage project. CPM, only time information, not cost, time information. Types of critical path method. Critical path method with a single time estimate. The second one is critical path method with 3 activity time estimate. And the last one, time cost model. So usually time cost model is PERT. Others are critical path method. First one, critical path method with a single time estimate. When activity time are known with certainty. If we know the activity time, each activity time in a project, then we call that single time, exact time. Then using this single time estimate to determine timing estimate for the project, total time, how long it takes, the project, determine project time using this single time estimate. Example, this project consists of 2, 3, 4, 5, 6, 7 activities. And then each activity has designation A, B, C, D, activity A, activity B, and so on. And next column, immediate predecessor. Activity A doesn't have immediate predecessor. That means this activity A is starting point of this project. Maybe not necessarily only one starting point, maybe 2, maybe 3. So if activity B doesn't have immediate predecessor, then B also starting point. But for this example, only one starting point, and then to start B after A. So it's like showing sequence. After A finish, B can start. And then C after B, D, activity D after C, E also after C, and so on. So using immediate predecessor, we can draw network. And then next column, activity time. 2 weeks to complete activity A, 2 weeks, 1 week, 1 week, and so on. So using this information, we can draw network diagram. First step, draw the network using node, and then inside of node, activity designation and activity time, and then using arrow, show the sequence. So in this example, activity A, starting point, so A, 2 weeks. After A, B can start, so B from A. C from B, and then D and E after C, F after D and E. G after F, and done. So using information, immediate predecessor, and then using node and arrow, develop this network diagram. Okay. The next step, determine early starts and early finish time. Early finish time, early start, early finish time on top of node. Later we will do late start, late finish, bottom. Okay, here, activity A, starting point, start time is 0, plus 2, 2. After A, B can start, so starting point is 2, and then 3 plus 1. 3 plus 1, 4. 4 plus 2 is 6. 4 plus 5, 9. F can start after D and E finish. D finish at 6, but this one still work. So after finish E, F starts. So after E finish, 9 start and plus 5, 14, 14, 15. So it's like when go this way, if there are 2 or more activities combined to 1, later or latest finish time goes to next start time. Okay, next step, determine late starts and late finish times. Hint, start with the last one and then go backward. 15, the finish time is now 15, so 15 minus 1, 14. 14 goes there, 14 minus 5 is 9. Go 9, 9 here and here. Minus 2, 7, minus 5, 4. And then go this way. Go this way. Later one goes here, but backward. 4 and 7. Earlier one goes there. 4, 3, 3, 2, 2, 0. Okay, I will tell you why it is the early start, early finish, late start, late finish. Okay, there is no space, but I will try. Okay, timeline. $15 and 0. Activity A start 0 and finish 2. So A 0 and 2. B starts 2 and finish 3. That is B. And then C start 3 and finish 4. That is C. And then D start 4 and finish 6. That is D. And E start 4 the same, finish 9. That is E. And then others, F starts 9 and then finish 14. And then F, G, finish 15. Okay, here, others, if A delay, then the next one delay. If E delay, then next one delay like this. But activity D start 4 because it takes 2, so finish 6. Start 5, 7, 6, 8, 7, 9, 8, and 10. So if D finish after 9, like 10, then entire project delay. So this one is not feasible. So available start and finish times 4, 5, 6, 9, 6, 7, 8, 9. So this is the start time and this is finish time. So as long as activity D starts until 9 or finish until 7 and 9, then entire project doesn't delay, it isn't delayed. So without delaying, D can delay like this. So start time 4, 5, 6, 7, finish time 6, 7, 8, 9. Among them, early start, early finish time for D, late start, late finish time for D. But others are the same. 0, 0, 2, 2, 2, 2, 3, and so on like that. Okay. So we call early start, early finish, late start, late finish because of this one. Critical path is the shortest sequence of connected activities through the network. True or false? Anybody?
That's false.
False, because earlier critical path is longest, right? So answer is false. here, in this network diagram, in this project, there are two possible paths. One is this path, and then the other one is this path. Okay, so two possible paths. First path, A, B, C, D, F, G. And then the other one, this path, A, B, C, E, and F, G. Adding activity times 2 plus 1 plus 1 plus 2 plus 5 plus 1, that will be 12. This path, 2 plus 1 plus 1 plus 5 plus 5 plus 1 equals 15. Okay, multiple paths. This one, because now there are two longer. If there are 3 or more paths, then longest. So this path, longer, longest. So this path is critical path. And then so the longest is critical path. So answer is false. Quiz number until quiz number 4. Solving problem. Quiz number 5. Until quiz number 4, single chapter question, solving problem. But quiz number 5, from chapter 1 to chapter 7. True or false, or and multiple choice questions. So true or false type question looks like this. So I will tell again about this quiz number 5 later. But quiz number 5, question type is true or false type and multiple choice. True or false type question looks like this. Okay, next one. Slack is the time activity, each activity can be delayed without delaying the entire project. Here, slack equals late start minus early start, late start minus early start, or late finish minus early finish. Activity A, slack A equals 0 minus 0 or 2 minus 2 equals 0. So this one 0 slack. This one also 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 0 slack. But this one 7 minus 4 or 9 minus 6, 3 weeks of slack. That means this activity can be delayed up to 3 weeks without delaying entire project. So positive slack, that means this one can be delayed up to that point. This path, critical path, on critical path, every activities don't have slack. 0 slack, 0 slack, 0 slack, 0 slack, 0 slack, 0 slack, 0 slack. So each activities in critical path, 0 slack, that means each activity is critical activity. If that activity delay, then entire project delay. So every activity on critical path, critical. But here, non-critical path, at least one activity has slack. Okay. So we call this one slack. Activity has a slack, that is non-critical activity, critical activity and critical path, non-critical path. So slack, this one, 3 weeks, non-critical. So this path is critical path. Critical path for this active project is A, B, C, E, F, G. And then duration, project time is 15. The same as critical path duration. That is project time. So using this critical path method, we can determine which path is critical and then how long it takes. The project takes time, duration. Okay, this one is practice problem on Moodle. You can find. This is not an assignment, but just to try, okay? Try. And then on Monday, Some of you are already look at the watch. So you expect to finish around this time, right? Okay. Okay, finish here. Okay. This one, your work. Try. So using activities and predecessor, draw network diagram, and then figure out how many possible passes in a network diagram project, and then which path is the critical, determine which one is the critical path, and then select for activity B and C. Next Monday, I will go over, and then next one. Okay, let me ask you, so far, any opinion about this class? Do you have any suggestion to make better? Is it okay? Okay, good, thank you. Good. Not for you, but then who took quiz number 2 already? Not for you, but if you missed quiz number 2 last Mondays, please set up time to make it up by Saturday. Okay, if you don't have a question or any concern, that's all. And see you Monday.
Take care.
Have a nice day. Thank you. Have a nice
nice
day.
day.
And you
Have a
can
nice day.
see you. Okay,
Good one.
good.
Thank you.
Thank you.
Have
All
a
right,
nice
thank you, bye.
Thank you.